Okay, good morning, Prof. In this video, I will be reviewing both the concept and application of set, relation, and function. Before that, let me introduce myself. My name is Kadek Diva Sapitri with a student ID 241301120 from class 4C Mathematics Education. Next. Okay, first, I will presentation about set. Okay, the topic of set by the simple topic to grasp in mathematics since we have to tackle just three simple questions. First, what are sets? The second, why do we need them? And last, how do we represent them? Let's tackle the first. What are sets? A set is basically a collection of things. Think about it. What if you were asked to make a list of all the things you can see? Of course, you cannot write all the things, but some of things you will mention are bird, a tree, people, and so on. And if you were asked to write down a list of things you cannot see, you would probably write oxygen, heat, and so on. These are the things you cannot see. A set is a collection of elements. Yes, but they have to be related in some way. So remember, another important characteristic of set is the element in it should be well defined and related. How do we represent a set of the first of four natural numbers? When we raster write a set of elements on a piece of paper, we cannot just write it randomly. Rather, you to find a way to can represent set. Let's see one of the way that we can write. Open the bracket 1, 2, 3, 4 and close the bracket. We use the curly bracket to mark the start and the end of the set. Inside the bracket we have elements, so each of these four numbers is an element. Sometimes we can represent with members. Don't forget, use comma to separate the element. This called listing or rusted method is a very simple way to represent set. All we have to do is list the element down. There is another way in which we can represent the set we just saw, that is the first four natural number. It is written as a set of all x such that x is less than 5 and belongs to natural number. I had exactly the same truth that you are going on your head right now. You would be thinking that the listening method is, is far simple and clearly as compared to writing in this way. But you will soon see this a very powerful way to write a set. I will explain its benefit in a bit, but for now let's just understand what it actually means. We will understand in detail part by part. The brackets have the same meanings. It says that what is written inside it is a set. Now, the next part is important. We have a variable here. We have we have called it x, but you can name it anything. So in our example, this can be read as all x. The colon means such that this is the first new things we learn here. A colon means such that. So this part is read as set of all x such that is mean that we have a few conditions coming up. Here we can see two conditions paired by comma. Paired by comma. This one and this one. The first condition is simple. It says x is less than 5. When we have this condition, since we are being asked for just first for natural number, but this condition is not enough as less than 5. Can mean anything decimal number or negative natural or negative number less than 5. And that practically why we have Why we have the second condition? It will make more sense if we read the whole thing aloud. It is read as set of all x such that x is less than 5 and x belong to a natural number and the natural number less than 5 are 1, 2, 3, and 4. This method is called the set builder method. Next, x is collect relation. So, what is a relation? So, a relation is give us a set of ordered pair that satisfy a relationship. Let's understand this using an example two set. We have two sets is P and Q. Set P has element 2 and 4, and set Q has element 10, 20, and 35. We, we first take the Cartesian product of two sets. Let's use an arrow diagram for the Cartesian product of set P and Q. So P cross Q is a set of the following order pair. It's two pair with each of these three and then four pair with each of these three. We get six order pair of the form P, Q, where every P belongs to P and every Q belongs to Q. That's how we can write the set builder form. Next. Now, let's introduce a relation R. Relation R gives us a set of all order pair that satisfy a relation. It could be anything relation. Now, suppose we introduce a relation R dash such that Q is multiplied of P. So we can say the relation R dash gives us a set of all order pair P, Q, where Q is multiplied of or of P. Every order pair in set R does satisfy the relation R does. This is the set builder method to represent R does. Please note the Q has to be multiplied of P here. Now, let's choose order pair from Cartesian product B cross Q that satisfy the relation R does. Look at the order pair. The order pair in the Cartesian products. Notice that 10 is multiplied of 2, 20 is multiplied of 2, and 20 is multiplied of 4. So we get the order pair 2, 10, 2, 20, and 4, 20 such that every order pair satisfied the relation Q is multiplied of P. This is the roasted method to represent R does. Roasted means list, so we can say that the order pair in set R does all listed like in a roasted. Set R does also represent using arrow diagram. We draw an arrow for every order pair in set R does. So we draw an arrow for 2, 10 and another arrow for 2, 20 and another arrow for 20. Next, let's say this entire circle represents the set of elements in the Cartesian product P cross Q. In this case, set R does will be a part of it. We can that set R does is subset of the Cartesian product P cross Q. That is the basic concept of a relation. A relation to give us a set of order pair and that satisfy a relationship. Next, we know that relation is a set of order pair that satisfy a relationship. This was the Cartesian product of set P and Q we've seen previously, and this is set R does. This is a relation here. The second number here multiplied of the first in each case. Now let's talk about term, range, domain, and codomain. We know that set R does has three order pair 2, 10, 20, 20, 2, 20, 4, 20. Here we can say that 10 is an image of 2 and 20 is an image of 2 and 20 is an image of 4. We can say that every Q is inside or does in is an image of its P. This set of P of all ordered pair B, Q in set R dot is called the domain. Or we can say that the set of first element of all the ordered pair in set R dot is called the domains. So we can say the domains contain the element 2 and 4. Now, it would be very easy to guess what range means. The set of Q and all ordered pair P, Q in set R dot is called the range. Or we can say that the second element of the ordered pair. In the relation, R is called the range. The range contains the element 10 and 20. So all the first element from the domain and all the second element from the range. So what is the codomain here? The whole set Q is called the codomain of relation R. So the codomain here will contain the element 10, 20, and 35. Now I want you to add the range and combine and find relation between them. What can we say? We should say that the range is subset of the codomain. Next, here is an arrow diagram to learn what is domain, range, and codomain. So, this is domain, this is range, and this is codomain. Next is function. We know that every function is relation, but not every relation is a function. Let's say there is relation R from set A to set B. How do we know this relation R is a function or relation? Can the type of mapping from set A to set B help us with this information? Absolutely. Let's us look let us look at the different type of mapping from set A to set B to know if the relation is a function or not. This is a type of mapping. It is one-to-one, one-to-many, many-to-one, and many-to-many. Okay, next. The first is the first type is mapping, which is the one-to-one mapping. We have set A and set B. Set A has element A1 and A2. Set B has element B2, B1 and B2. Now we can say that the relation from set A to set B has as a one-to-one mapping. We can say that when each element in the range is an image of exactly one element in the domain. Here are domain. Here are domain. Here are our domain has element A1 and A2, and this is our range has element B1 and B2. So we can see that B1 is the image of exactly one element A1 and B2 is the image of exactly one element A1. If the mapping is one-to-one, the relation is a function. Do you know why? This is because every element in set A has one and only one image in set B. As we had seen in the previous lesson, this is the only condition for a relation to be a function. Next. Now let's look the second type of mapping, which is one-to-many mapping. Now we can say that the relation from set A to set B has one-to-many mapping. This is when an element in the domain has more than one image in the range. Look at this row. This is A1 has two images B1 and B2, and A2 has image B2. If the mapping is one-to-many, then the relation is not a function. This is because an element in set A has more than one image in set B. From it to be a function, every element in set A must have one and only one image in set B. Next, let's move the let's move on the third type of mapping. Now here the arrow diagram for many to one mapping. Notice that A1 and A2 both have the same image B1. Can you tell me if the relation will be a function in this case? If if the mapping is many to one, then the relation is a function. This is because every element in set A has one and only one image in set B. Doesn't matter even if it's the same image, the relation will be a function in this case. Next, and now we come to the last style many-to-many. Here's the arrow diagram A1 has two images B1 and B2, and A1 no, and A2 also have two images B1 and B2. Will the relation be a function in this case? I think no. I think no. So, what do you think? If the mapping is many-to-many, then the relation is not a function. This is because more than one element in set A has more than one image in set B. Next, hope the concept of mapping is clear. Now we saw that when the mapping is one-to-one and or many-to-one, the relation is function. But when the mapping is one-to-many or many-to-many, the relation is not a function. Next, now we move to type of function. There are three types of function. First is injective function. An injective function is a function in which each element of the codomain is related to at most one element of the domain. It also called a one-to-one function because each element in the codomain can be paired with only one element from the domain. The second is surjective function. A surjective function is a function in which every element of the codomain is related to at least one element of the domain. It is also known as an onto function. The third is bijective function. A bijective function is a function that satisfies both the property of injective and surjective function. It is also called a one-to-one correspondence because every element in the domain is paired with exactly one element in the codomain, and every element in the codomain is paired with exactly one element in the domain. Okay, that's all for me. Thank you.